Let's start the course with an introduction to Docker. Docker is a containerization platform, means it first allows you to bundle a full-blown application as an image. This image can then be run as a container on any host, which runs Docker. It very easily fits into the continuous integration and delivery mode, as the Docker images can be built in an automated manner, pushed to a Docker registry, and then containers can be run from those images. We will cover these topics in detail as we proceed with the course. Docker containers are extremely fast to come up, with most of the containers having the startup time of less than a few seconds. An inherent property of Docker containers is that they always start in the same manner. Docker host is the machine, physical or virtual, on which Docker is installed. One host can run multiple containers on itself. There is isolation maintained between the individual containers using namespaces and control groups behind the scene. As we all know, microservices-based architecture is increasingly gaining momentum and is fast replacing the monolithic application building style. Docker is a key technology for managing and deploying microservices. A container is a unit providing a single service. Rather than having just one replica, Docker allows us to run multiple replicas of a container. This provides the required capacity to the service and also adds a level of reliability. In this slide, let's talk a bit about Docker containers. A Docker container is a running instance of a Docker image. So, you have a Docker image which has all the prerequisites bundled all together. This Docker image is easy to share with others. You take the Docker image onto your Docker host and you run it. That running instance, which provides you the desired service, is the Docker container. The image by itself doesn't provide you anything until you run a container from it. Take a look at the diagram on the slide. You need to have a host operating system on the infrastructure that is to be used. Docker Engine is installed and runs on that operating system. Docker uses operating system level virtualization for running the containers. Each container shares the kernel of the host operating system only. They just add user space on top of it. One container is isolated from the other running containers on the same host. Even though they share the kernel, each maintains its own user space. That is, there are boundaries defined and followed. Conceptually, this all sounds similar to virtual machines, isn't it? It might, but that's not true. Containers are not just lightweight virtual machines. There are fundamental differences in these two technologies. Virtual machines run on hypervisor, which provides virtual hardware resources to each of the virtual machine. Each VM has its own operating system running on those virtual hardware resources. Whereas containers just have their own set of libraries and binaries. They share the kernel of the host running the Docker engine. A container provides the user space of an operating system. Hence, containers are an abstraction at the application layer, whereas virtual machines provide abstraction of physical hardware.